MAP4C 1.5, the cosine law. Previously, we have learned about Pythagorean theorem as well as primary trigonometric ratios. And in both of those cases, that applied strictly to right triangles, or triangles that contain a 90-degree angle. Then we learned about the sine law, and today we are adding the cosine law to our tools to be able to solve for missing lengths and angles within triangles. Both sine law and cosine law apply to both oblique and right triangles. So we're going to look at the criteria that allows us to apply this technique called cosine law. So it says in any oblique triangle, ABC, we can use this formula or this formula. Now let's first note that this is what is isolated, c squared in this equation. So that c, remember that lowercase letters denote side lengths in a triangle and that capital letters represent vertices. So if this is isolated in the equation, that should alarm you that this is a formula that is used for lengths. And then this version here, because it is cos of c, that is an angle that's unknown on the left-hand side. And since it's isolated, this is the cosine law for angles. These two formulas are the same formula. It's just isolated for a different variable in the equation. So, that being said, what we're going to do is look at the patterns that exist for the application of cosine law. So, I'm going to explain the T pattern in two different scenarios. Case 1, side, angle, side. So here we have in a sequence side, angle, side that is known. And on the opposite side is a side length. And we can determine that side length using cosine law. So what is missing right now is a length. So we'll use that version of the formula, where a length is isolated. Now, if we can think of drawing this over top, and the vertices may be labeled as different letters, but just focus on this relationship here. A and B as a segment, and then across this T pattern, C in this formula represents the length that is across from the side angle side. So, let's substitute into our formula accordingly. If A and B are 8 and 7, and the angle for C, remember that if this is the length C, then this is the angle C, even though our labels are different. So when we substitute in, that's what's required as inputs on the right-hand side of the equation. We would say, in general, this is the formula we're using, and then in the next line, substitution as it applies specifically to this problem. So, y squared is equal to 8 squared plus 7 squared minus 2 times 8 times 7, because that's A and B in this case, cos 50. Next, we're going to evaluate this, and depending on your comfort level with your calculator, some have a display, and you can do this all in one line, but you may want to have the parts which are being added together first and calculate the part which is being subtracted second, and do that in multiple steps. You should end up with 41. Now, on the left-hand side of the equation, we haven't isolated the variable. We have isolated a variable when it's a coefficient of 1 and a degree or exponent of 1. So, y squared, the opposite operation of squaring, is to take the square root. And the square root of y squared is y. The square root of the right-hand side of square root of 41 is approximately 6.4. So, we've solved for that length, which is across from the side angle side using cosine law. Let's look at case 2. Another scenario is side, side, side. 3 sides are known in a triangle. And if 3 sides are known in a triangle, we can determine any angle within that triangle. However, the way that we substitute into our formula, remember that one version is for missing angles. It's the part that has cos C isolated. So if you draw this T pattern, you can determine, in this case, we'll call this angle C here, but the angle that's across the pair of the length and angle is C in this case. So we state the formula in general because that's how it applies in a general sense, but let's apply it to this context. Cos C is the angle that we're looking for. So that opposite pair of length and angle is what we're going to be substituting in as C, but we'll call this angle Q. So cos Q is equal to, and then A and B are on the left and right hand side. And C is the length which is across from the angle. So again, we can calculate the numerator, determine its value, and then divide by the denominator once we've evaluated what it's equal to. Hopefully you're comfortable using brackets. You can put the numerator in brackets and then divide it by the denominator in brackets and do it all in one step. So you'd end up with the value negative 0.3409. And we haven't isolated the variable by itself at this point. Whenever we have cos of the variable Q, the variable is not isolated. So the opposite operation of cos Q is cos inverse. So we take cos inverse of both sides. This has the property that cos inverse of cos Q is equal to just the angle Q. And on the right hand side, you can see that we've taken that value and we're going to use our calculator, making sure we're in degree mode, and it will be approximately 110 degrees. So this is one example of each case, but another skill is making sure that we know when it applies. So let's look at some cases and see when it will apply. Which of the following unknown values can be determined by applying cosine law? And hint, can you apply the T pattern? Another way of thinking of this is, do you have side, 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 or side, angle, side? All right. In this case here, can we apply the cosine law? And the answer is yes. I see side, angle, side, and across from that is the unknown value that we're looking for, A. So yes. Next, you can pause if you'd like to answer this on your own. Can we find E using cosine law? And the answer is no. If we were to draw that T pattern, we don't have side, angle, side, and an unknown value across to determine that value E. So no. Next, can we determine the length of measures G? And the answer is no. We don't have side, angle, side. So we would need side, angle, side to be able to determine that length across. And lastly, can we determine angle K? We have three sides, so as long as we have our T pattern with the correct orientation, where we have the opposite angle K and length K as 17 in our formula as the variable C, we can apply cosine law. Good luck.